Welcome back to the motor rebuild series. Now it's time to do the actual rebuilding. Well, first we've got to do a bit more cleaning and thread chasing, but after that we'll put some pistons in. I recorded the full rebuild start to finish as one video, but it turns out that that was ridiculous. We were looking at a video that would have been more than 2 hours long. Not very practical for someone wanting to find the piston part or whatever. So I've split it up into 7 pieces and they will take us through to a fully assembled motor. Now these videos are intended to be a reference for the guy who's actually rebuilding his Land Rover motor, so they are long and boring. And by reference I mean, it's nice to see another guy do what you're about to do sometimes. But these are not a replacement for your workshop manual. You need a workshop manual because they contain the instructions. I recommend the official Land Rover workshop manuals. The Haynes manual is pretty good so far as the engine goes, and you could definitely rebuild your engine with it, but the official manuals are better, more thorough, more diagrams, so that's what I would recommend. We're going to start with the core plugs. I've got a new set of core plugs from Turner's. I don't think we need all of these, but I think there was some variation across the years, so they supply a few extras. This one up front is the least visible when the engine's assembled, so let's start with this one. First job is to make sure that the hole is nice and clean. There's going to be 50 years worth of corrosion and crud, so that all needs to be cleaned off. Now, we need to use some kind of compound on these. I was intending to use this, Permatex number 1, which is pretty much made exactly for this purpose. I'm not going to. You could alternatively use green Loctite, the retaining compound, but I'm not going to. Instead, I'm going to use shellac. The guys who did the machining for me, when they replace core plugs, this is what they use. It's the traditional method, and I like that. I don't know, there's just something romantic about using insect secretion on your motor. Now, so far as Land Rover were concerned, these plugs came from the foundry as part of the block, so they don't have individual Land Rover part numbers. So I'll put the sizes on screen so that you can order them individually if you want to. Sizes may have changed over time though, just be aware of that. Make sure the writing is up the right way, obviously. Installing the plugs is easy in theory, you just bash them in. But you do have to make sure they go in square, that's the main thing. You can use sockets, but you have to bash these plugs pretty hard, so you'll probably ruin your good sockets if you do that. Don't copy my ones, I just happened to have a piece of plastic that was easy to cut into circles, but they're a little too bouncy. The point is you need something that's going to hit the bottom of each plug around its full circumference. Now, I'll just point out that you can get different types of core plugs. Brass, stainless steel, and zinc-coated steel. I'm using plain zinc-coated steel plugs, partly because that's how they come if you buy them as a set for this motor. Also, if this motor ends up in a higher end restoration, that is the correct original finish. That's also why I didn't paint over them. And every OEM manufacturer uses zinc-coated steel plugs. They're going to last 100 years if you run proper coolant. In saying that, brass is preferred by a lot of engine builders because brass doesn't rust. So, use brass if you want to. I would personally prefer to use stainless steel plugs, but the range of sizes available in stainless is more limited. The larger imperial sizes just aren't readily available. Now, on the topic of core plugs, if you're trying to find these on Google or asking about them at the auto store, they're also called freeze plugs, expansion plugs, and Welch plugs. Freeze plugs is a bit of a misnomer, the idea being that they are designed to pop out if the coolant inside the engine freezes, which would save the block from cracking. That's not true, or at least that's a happy coincidence, but the name has stuck. Welch plugs are a specific type of plug with a dome shape. You hammer the dome flat, which expands the outer edges, creating a seal, invented and sold 100 years ago by someone called Welch. Something like that. And that's not the type of plug we're using here, but sometimes they're called that. In reality, all 4 names are used willy-nilly, so if you're trying to buy plugs at Repco, you might have to ask the guy 4 different ways, after you give him your rego, of course. You'll see in the next lot of footage that these big plugs are missing, this being out of sequence. Because I messed one up and had to order another one. Locally, it wasn't a big deal. I think they cost $4 each. In fact, I bought 3 new ones so they would match. Also, there is this plug in the centre of the head, and that's it for this motor. The next job is to go through and clean out all of the threads. I want to do this now because that's kind of dirty work. We're going to blow a lot of stuff out of the holes. Now, a lot of people get confused when it comes to Land Rover threads. Whitworth, metric, imperial, BSF, UNF, UNC, BSW, BA, BSP. The good news is that when it comes to these 2¼ litre engines, pretty much everything is a standard American imperial thread. So UNF for fine and UNC for coarse. And really, there's only a few 1/4" UNC threads, everything else is UNF. It is important that you clean out the threads for your head bolts. If you really don't want to buy a tap, you can cut a hacksaw slot in a head bolt and use that instead, but then you'd be one head bolt short, so probably just buy a cheap tap. And just some tap buying advice, hand taps come in 3 flavours. Intermediate taps are what you're going to get with every tap and die set, and they're fine for what we're doing here, although a bottoming tap is probably more ideal. But if you want to actually cut threads in the future, a tap and die set is probably a bad investment because what you're going to want are the taper and bottoming taps for each size. And now the messy part. I'll do the first one with no rag. You can see why you don't want to be doing this once the engine is half assembled. As far as all of the general bolt holes go, I clean all of them out properly with a tap. There's nothing worse than assembling a motor with crusty threads. Now, I mentioned that there were a couple of exceptions to everything being a standard American thread. So let me introduce you to British Standard Pipe. Land Rover used BSP threads for the sump plugs, the coolant fittings, and a few other places like the top of the inlet manifold. And before we hassle Land Rover too much about using some antique thread form, BSP is in fact widely used even today. In fact, it may be the most common pipe thread in use, especially when combined with the Japanese pipe thread, which is the same. Now, one thing about pipe threads is that they are quite difficult to identify because if we measure this, 16.54 millimeters, which is 650 thousandths, and this is a 3/8 BSP plug, and you will note that 650 thousandths is nowhere near 3/8 of an inch. And likewise, this one is 1/4" BSP, and you can see that it measures more than half an inch. And the reason why these don't measure anything like their actual size is because pipe threads are sized based on the internal diameter of the pipe that they work with. So your air compressor, for example, probably has 1/4" BSP threads in it, and so that's your system. Whatever fittings and couplings and clip together things you buy, so long as they say 1/4" BSP on them, they will work together. That's the idea. Now, within that system, you have 2 types of threads, parallel and tapered. Now, my understanding is that in the BSP world, the female thread is nearly always parallel. And by parallel, I mean a standard thread like you would see on any nut and bolt. And where tapered fittings are used, it's normally just the male fitting. So, regardless of what fitting you use, if you're buying taps, make sure you get the parallel thread taps, not the tapered thread taps. Okay? To make things even more confusing, BSP P, P for parallel, was changed to BSP F, F for parallel, and then changed to G for parallel. Most likely, at least in New Zealand, these are going to be listed as BSP-F and then the size. And the 2 sizes we need for this engine are 1/4" and 3/8. This hole here is the coolant drain hole for your block. So on most of our motors, there would have been one of these taps fitted in here. And the idea is that when you drain your coolant, you open this and let the coolant out. If you just drain the radiator, you miss all of this coolant in the block. Now the problem with these is that the plugs always get jammed up and they don't work, and then somebody gets this out with a spanner and mangles the nut, which is what's happened here, not by me. So anyway, we're not going to put one of these back in. The later option was a standard plug. That's what we're going to use. I figure if you're changing your coolant, you probably have a spanner, although this is a Whitworth size. 1/4 inch Whitworth, in fact. See, the system works. Anyway, let's clean out the threads. Okay, so this is our 1/4 inch BSP tap. I'll just put a little bit of grease on here to catch the debris. This motor is assembled now. I should probably point out that I filmed this pipe thread part at the end, so ignore the fact that the motor looks finished, because it is. Don't worry about it. Not that a little bit of gunk in the coolant system is that big a deal, but of course, completely different in the oiling system. We can't be doing this in anything connected to the inside of the crankcase now. Nice. Look at that crud. This plug is just like a standard bolt, it just threads in. It has a parallel thread, like so. And the idea is that you use a washer underneath the head to do the sealing. Instead, I'm just going to use thread sealant. I like this stuff, it works really well. And this stuff is good too because it'll stop the threads corroding. You normally don't use this much, but I don't mind pushing a little bit extra in this case. Okay, easy peasy. Next, we've got these larger threaded holes on the head to clean out. And there are in total 3 of these on the head, or in fact 2 on the head, 1 here at the back, 1 in here behind the thermostat, and the 3rd one on top of here. So 2 of the holes are for your heater pipes if you're lucky enough to have a heater, and 1 of them is for the temperature gauge, or the temperature sensor. These threads get a pretty hard life, obviously being inside the coolant system. I do need to order some new plugs. I'll put nice new ones in this motor. I've only got 1 anyway and I need 3. Well, I mean, I suppose I could hunt around and find some more, but I'm going to get some new plugs, that's what I'm trying to say. Okay, moving on. And this is also the time I want to make sure all the gasket surfaces are ready, so that we don't have to worry about getting grit or shavings or whatever inside the assembled motor. Okay, we're at the point now of the final cleaning, which means basically washing the motor. But on this one, I'm also going to clean out the oil galleries. Let me give you a quick rundown of the oil system on this motor. The oil pump sits down in the sump and it pumps oil up into a cavity and behind here, which feeds into the oil filter. The filtered oil then re-enters the motor into the main oil gallery running long ways through the motor. If you take the plugs out of either end, you can see right through. And that main gallery branches off to the crankshaft bearings. You can see the holes coming through here, and also the camshaft bearings. There is also a connection going up to another oil gallery that runs through the tappets, but this one is all open, so you don't really need to worry about especially cleaning it. I'm sure there are special oil gallery cleaning tools, but I just buy the cheap spray gun cleaning kits and sticky tape the brushes to a stick. High tech. Now, I didn't do any of this when I rebuilt the motor for my Rover. If it's a motor that you've been running with no problems and you're just refreshing it, then bottle brushing your oil galleries is maybe a little over the top. But I don't know the history of this particular motor, so the only way to make sure everything is fine is to make sure. Obviously, you want to be super careful around oil galleries because they are after the filter. So anything that you leave in here is going through the bearings. You will notice we have another oil plug here. This is the main gallery here, and there's another one here. And that also runs full length of the motor right through all of these tappet holes. And here's one of the sleeves that fits down inside these holes. So the oil's coming through here, it hits this, runs around the recess onto the next hole. And what's interesting is that this entire oil gallery is fed via the front camshaft bearing. Oil comes up through this hole here, it goes around the bearing, and then if I flip the engine upside down, it goes out through this tiny little hole here into the tappet system. So double check that there's nothing blocking that hole. I cleaned it out with a piece of soft copper wire and then flushed plenty of brake clean and compressed air through it. Now I spent a lot of time with brake clean and degreaser and compressed air, making sure every passage was completely clean. And then the final step is a wash with soapy water. And from this point on, you need to keep the motor really clean. So you can't be angle grinding your rusty chassis while your engine is being rebuilt. It only takes one bit of grit in the wrong place to wreck a bearing or score a cylinder. And I'll just put some spray on everything so it doesn't go rusty. And the first bit of assembly we're going to do is to put the oil gallery plug back in. And I'm putting this in with plenty of Loctite. And this tightens up against absolutely nothing, hence the Loctite. It's a little stiff because of Land Rover's previous peening, which isn't 100% clear, but that's fine. Alright, that's where it used to be, I can tell by the big hole. And now we're just going to punch the threads, how about right here. And that's the block all clean and ready to go. In the next video, we'll be installing the crankshaft. See you there.